G'day, I'm Jake from Firepants Fab. Just want to tell you about the latest project, and this is sort of a instruction or guide video for converting one of these black diamond 40-ton log splitters into a forging press. I'm going to be supplying a kit that consists of the base and the anvils and all the bits and pieces and hardware and electrical stuff and whatnot to convert one of these log splitters. We get these from Paramount Browns. They're sitting at they're just under $1,700, which is for what you get with your cylinder, your control valve, hydraulic motor. You've got the hydraulic tank. You've got the frame and a few other bits and pieces. I think that's a really good deal, so I jumped on that, and this is now the second one that I've made. The first one was just from scratch. This is the first one using the kit, so treat this video as a guide, not your solid instructions. Each kit will go out with a set of written instructions, and I might even do another video to follow up any changes that we make. So follow any written instructions, because that'll be more up to date with any changes to the kit that we've made. So you will have a few spare parts from your kit, like you get a 13 horsepower motor, a drawbar, a couple of wheels and stub axles and bits and pieces. So if you're like me, you'll have you'll have 1,000 other uses for the other bits and pieces that you get in the kit, which is a bit of a bonus. Otherwise, sell them, whatever, recoup some of your money. Yeah, check out in the description, I'll put links to where to purchase my kit from and where to purchase the splitter from. As I said, it's Paramount Browns. They do ship Australia wide, and I checked out they are based in Adelaide. As I said, at the moment the 40-ton splitter is touch under $1,700, and for example, freight to Perth was $300, so $2,000 gets you the splitter delivered to Perth. I think it was about $150 to Queensland, to Brisbane at least. You know, have a look on their website, see if it's the right one for you. You can find something locally. There are a few other companies selling the black diamond, Miller Falls black diamond log splitters. If you can find one local, that's great. Save yourself the freight. But if not, that option is there to get one sent anywhere in Australia. I won't be selling the splitter. I'll only be selling the kit that goes with it. But building these things is actually pretty simple. I've tried to keep it as ergonomic as possible, so control valve is at a comfortable height for me. Dies are, some say it's good, some say it's not. That's up to you to decide. They're sitting at about shoulder height, which, two things: we didn't want to have the cylinder all the way up on top to keep this thing fairly compact and whatever, and then we'd also have the control valve up here. May or may not be a good thing, but this is just how I set it out. Hydraulic tank is at the back and it's above the pump, which you probably can't see, sitting down there. Electric motor, 3 options for your motors as well that we can supply, or you can source your own as well. Basically, they are the same options as our Scorpion grinder, so a 2 horsepower fixed speed, a 3 horsepower fixed speed, and a 2 horsepower variable speed. So this is set up with the variable speed because I like to be able to slow it down. I've used mine for pressing in bearings, bending sheet metal, all that sort of thing. Things that you're not just going crazy trying to squash steel as fast as you can. You'll be able to see on our website the price difference between going the variable speed and the fixed speed. And like I said, you can source your own as well. If you do want to source your own, please just let me know, and I can tell you exactly what frame size, what mounting type, what mounting you need on your motor, any of those specs. I'm more than happy to tell you what you need. Whether you buy it from me or not, it makes no difference to me. I just want more people using presses. Yeah. Let me know if you need any more info like that. It's best to leave a comment on the video, but you're better off checking out the website. As long as I remember, I'll list what I know that you need on the website. Otherwise, send me an email. Alright, what you can see behind me is the Miller Falls Black Diamond 40-ton log splitter that we are going to convert into a forging press. So we're going to use most of the parts that are in this kit. Some of them we won't use, so we'll be putting them aside. And there's a kit of additional parts that I've made up, and we're going to show you how to combine the two to get your forge press going. First things first, as it is, it's pretty heavy, so I'm going to be unloading the box piece by piece, and most of it's easy enough except for the main piece here. I'm going to be taking the cylinder off because we need to do that anyway for the assembly, so I'll do that now while it's on the back of the ute, save me busting my ass lifting it over onto the table. I'll run through as I go the parts that we're using and the parts that we're not. The parts we're not using, keep them aside for a spare project, sell them on Gumtree or eBay or whatever. Like we just don't need them for what we're doing. There's an exception to that I'm setting this kit up to use an electric motor. If you don't want to go that way and you want to use the petrol motor, go for it. It'll just be noisy and you'd want to mount that outside your workshop, and maybe some longer hoses, but yeah, essentially that's a great way to do it, just not very convenient for me and for most other people. So yeah, we're gonna just get all our pieces where we want them, and some stuff we are going to have to modify a little bit, cutting brackets off here and there, and basically cleaning things up. So I'll run you through what's happening, but yeah, some parts we just don't need, so we'll get rid of them first and lay out what we do need, and we'll work our way through it. Alright, now we've got the frame. I just tipped it out of its box. Next step, we're just going to show you how to pull the cylinder off. It's pretty simple. There's just a pin on the barrel end, and there is a bolt that goes into the wedge. We're just going to pop that bolt out, slide the wedge forward, and drop this pin out. It's just a 22mm on the nut side and a 21 on the bolt head. Watch your fingers. Slide that out. Put the bolt back so you don't lose it. And we should be able to grab the hoses. And slide the cylinder out. Right, now being the heaviest part, I'm going to just straighten it up and leave it on the ute for a minute while I get the last piece off that we don't need. And then I'll struggle with this in a minute and get it on the bench when we're ready for it. One last thing to do now is just take this wedge off, because it's got to come off anyway, and makes it a bit lighter and easier to move this around. All we need for that, 19mm spanner and a large flat screwdriver. Only need to remove one side because then it just slides off. Alright, so here we have the collection of parts that we don't need, and you can just put them aside. I'm going to use these for another project. Not sure what yet, but that might be an interesting video to put up later. So we've got the drawbar, don't need that. Petrol motor, we don't need that unless you want to run this on petrol. We've got these two, they go either side of the frame. They're for catching logs, or so that logs don't roll off or whatever. And this locks into one of them. It becomes a bigger table. There's a larger plate of steel that bolts onto that, but we're going to use that as a guard on the press. So these bits we don't need. There's a one of these. I have no idea where it goes. Let's leave it that way. This is the motor mount that bolts onto the hydraulic tank and underneath the motor. Not using the motor, we don't need this. Got two of the mud guards, two tyres, and the pair of grease caps for the wheels. So yeah, all of this can go away. We'll put this in a pile. We'll add a few more pieces to it as we cut them off the rest of it. Yeah, then we can get started on. Alright, now we're just left with the items that we need to either modify or we can use straight up. So we've got the frame, we've got the hydraulic cylinder with the valve attached, we've got the hydraulic tank, we've got the hydraulic motor, we've got a bottle of hydraulic oil. Now this is not very good oil, but use it for the first couple of hours to let the machine run in. then change it with something nice. We have the wedge, or what's left with the wedge. We do have a box of, I can't remember what's in here. Bolts and mounting bits and pieces and whatever. Use as much of that as possible. And probably hard to see back there, but we do have the fire pants press kit. Keep in mind this is the kit Mark 1. There's likely to be a couple of changes between this and what we actually make available. It'll be fairly minor changes, and I'll try and capture the differences and whatever if there's anything different in the assembly, but most likely it'll just look a little bit different. So what we are going to do next is I'm going to start modifying the frame and modifying the hydraulic tank by removing, flip it over and remove any of the brackets or any of the fixtures that are welded onto the back of the frame, and we're going to mark out where to drill some holes to mount the upright bracket for it. And same with the hydraulic tank, we just need to cut off the axles, and I'm pretty sure that's it. Yeah, we cut off the axles and then we can start building up the frame. We'll cut some steel to make the base, and yeah, put the frame on it, bolt the tank on, and start working our way up. Probably the last thing we do will be to modify the wedge. We've got to cut the point off the wedge and weld on anvil blocks. That's going to be our working surface for the press. Alright, I've just highlighted here on mostly on the back of the frame. Everything in pink is coming off. So these two brackets here, these two bushes for the drawbar, this handle under here that's used to flip it up on its end, and there's 5 little sections on that are used to catch the piece of wood just to give it a bit of grip, so they're getting ground off as well. And on the bottom of the hydraulic tank, we're going to cut the axles off. You can just cut them square off to the side, that's by far the easier way, but I want to reuse these on another project, so I'm going to spend the time to cut them out with the angle grinder, just work in from each side and try and get them off in some sort of usable fashion. Before we do anything, we're going to cover over the outlet of the hydraulic tank, just with a bit of tape, just to stop dust and grinding crap getting in there. Bear with me while I get them done. Alright, now you can see we have taken our axles off the hydraulic tank, and the rest of these small parts that I'd marked out earlier. I cleaned up and painted all the surfaces where I did sort of take a bit of paint off, just to sort of keep it neat as I go. All of them except for this face here, where we took the ground off those little pieces of steel for grabbing onto a log. That's because we're going to be welding onto that face later and keep it nice and clean, and we don't really, it's better not to have any paint between the anvil that we're going to weld onto it. We cleaned out all the paint off that face there, got it nice and flat enough with the grinding disc anyway. Just want to make sure we can get a decent weld on that when we get to it, just easier to do it while we're there. Alright, now that we've cleaned up our frame and our tank, what we are going to do is we need a back support piece from the kit, and our tank support, which looks like that. It's got the 4 slots close together. There's another one similar that actually bolts to the tank, but if If you go by what that looks like, can't go wrong. So this goes with the 4 slots towards the top. Sits about there. And this goes, you'll want the, this part here is for the motor, and the motor sits on the left hand side when you're using it. So we want it on our right hand side. Now what we need to do with this piece is get it centered. I've marked a center line on both pieces and approximately where it needs to go. So that there, I'll have a notch cut out to show center, top and bottom, or maybe even for the width of the thing, just to make it a little bit easier. But what we need to make sure is that the lowest section here can't be more than 100 millimeters from this edge here. So I think I've set this up at about 90 mil. Just going to take a big square, sit it over that so it's touching the bottom, and yep, bang on 90 mil. So there'll be 10 millimeters to spare between this point here and the floor. That's fine, we just need clearance. Now that we've got this piece, it's square, it's in line, we've checked the centers top and bottom, and we've got this edge here less than 100 mil from the bottom of this. We're good to clamp this down. Now this top piece, we want 220 millimeters between the top of this plate and the bottom of this one. This one's easy to line up because it's the same width as the back of the frame. So we just slide that up, 220. We can put a clamp on that too. Right, now that they're clamped in position, we're going to mark out the holes. So we're just going to, while it's all clamped, we'll center punch each of these holes, and we're going to drill them out at 12 millimeters. Now this step is, it's possible with a hand drill. If you can fit it in a drill press, do that. Easiest way to do it, well for me, is going to be on a mag drill, but I'll drill a few by hand just to prove that it's possible. It's just a tedious part of this process. Once they've been center marked, we can take them off. You could use that as a guide for drilling, but I don't like doing that because if you drill wonders, it tends to just flog everything out. It's just a bit nicer doing it this way. Now you see I'm using a pilot drill. Trying to get a 12mm drill bit through by hand is pretty difficult going, so I'm going to be lazy, use a pilot drill and just get it done. Just don't go too big with your pilot. It shouldn't be much more than the, if we can get it on here, it shouldn't be much bigger than the center, which is called the chisel edge on your other drill. Don't go up half a millimeter or a millimeter at a time. All that does is burn out the outside cutting edge on all of your drill bits as you go, so it's a good way to stuff a whole set in one sitting. Right, now that we've got 8 holes drilled for the base and the 4 more for the hydraulic tank holder, we're going to put this aside and start building up the base so we can bolt this up to it. So, back piece, we've got this funny looking support that ends up going in there. But first, 50 by 100 RHS, got 2 700mm and 1 800mm pieces. The 2 700s go like that. Alright, so I've put a weld on each of the corners, front and back. It's nice and sturdy. The only place we don't weld is on the inside of here because that's going to get in the way of the frame. So it's welded fully down the other side. So these sides are 700mm long, that's 800mm wide, outside to outside, which gives us enough width to get our pallet trolley in here to be able to move it around. This piece here is 300mm from the edge. That squares it up nicely, and that gives us forward and back support. We can't have one on the other side because the hoses for the cylinder will get in the way. We've got 50mm gap at the front here and almost 250 at the back, because there's quite a bit of weight hanging off the back of this thing, so it just makes it nice and stable, keeps it as compact as practical. And we're ready to put this on the ground and put our frame in it, stand it up, and continue from there. So we're using M10 by 35 bolts with nuts and washers. I'm going to try and lift the frame up to it because that's the lightest part. If this works, I'll keep it in the video. If it doesn't, I'll just cut it out, do it a different way. Look at that, beautiful. Bonus points to get the washer and nut on in one go with one hand. Time to stand it up. Now that we've got it upright, we are going to chuck the cylinder back in, and it's just going to sit around the bottom. We'll probably chuck a cable tie or a strap around it just to hold it in place. Next bit, we're going to sort out the tank, the bracket that bolts onto the back of here, and the tank bolts onto the bracket. So that goes on the back. Got two of these gussets that go into there, and that piece there, and then this piece ends up bolting to the tank, and it sits about there. So I'm going to go ahead and weld this up, bolt it onto our frame, and then bolt our tank up into place, and we can get our hoses at least sitting up in the right spot. Well, now that we've welded this up, closer view there. So it really can only go one way. These holes are offset, and those ones are as well. So if it doesn't fit just like that with a bit of a gap, it's all gone terribly wrong. Right, we're just going to bolt this up using the same bolts as we did earlier. Now you'll note that I only did a few little stitch welds, maybe 20mm long in 4 spots, 8 spots in total, here and then on the inside of here. But that's all it actually needs. So any welding in this job, it's only holding up some weight. It's not like nothing's going to take the force of your 40-ton cylinder. So I mean, all this is doing is holding up a hydraulic tank that maybe weighs 20 kilos. With oil 30 kilos, so yeah, a couple of stitch welds is all it needs. We find the hardware to bolt the tank onto this in this little box with a bag of all sorts of stuff in it. So we'll have a rummage through that, and I'll try and make sure I get the right ones. So if you look through your bag, they're actually the M10x30, and there's these come with nylock nuts, so we'll use them. The next part of this project is we're going to modify the wedge. So obviously this is the splitting wedge and it's no good to us. So from this top edge here, we need to measure down 90mm, and we'll use a square to do that, and we'll mark it on this edge here because I'm going to sit it in my bandsaw like so, and we're going to cut down, and it's almost going to get to the bottom. Then we'll just have to cut along this weld with the angle grinder, give it a few taps, and we should be able to break out whatever the last little bit is and tidy it up in the corner, because that's where these little anvil plates are going to be welded. So there'll be one here which will sit about there, and there'll be another one welded to the top of the press frame. But we'll need to make a few mods to them as well. Drill and tap a hole in the front for our little lock. Show it down there. And weld on a pair of angle iron strips. That'll be our die holding strips. We've got a couple of these plates made up. They will slide this is what we're going to mount our dies onto. So we can slide these into the angle iron channels. They're supported by the heavy anvil plates, and then whatever we want we weld on top of this, whether it's a couple of V's or some drawing dies or some squaring dies or whatever. So first part of the process, we're going to mark 90 millimeters from this top edge over here, set up in the bandsaw and cut the top part of the wedge off. It would be possible to do it with an angle grinder, working in from each side, because we're cutting about there, so 5" probably isn't ideal. If you're really excited, do it with a hacksaw, but I've got a bandsaw, so I'm not going to do that. Of course, you could always blast it off with an oxy. I don't have one of them, but that'd be a pretty decent way to do it. Just set it up and go your hardest, really. Yeah, you do want to get that as flat as possible, but there's always a little bit of adjustment that you can make when we go to weld it on. So at this point I've cut down here with the bandsaw. Now I just have to cut out this bit of weld. I'm just going to use a 5" angle grinder. So we want to cut out that part there, and the same on the other side. Hopefully we've gone deep enough that once we get through that weld we can just bash it around with a hammer, a bit of side to side, and whatever's left in this corner here will tear out. I'm not too concerned about going a little bit past where we've cut. We've cut there. It's hard to see on the camera. If we go a bit past, we're going to be doing some welding on this anyway, and if there's a bit of a cut, we just have to V it out a little bit and we'll fill it up along with wherever we were welding this anvil block on. Of course, we just want to do the minimum amount we have to, but yeah, don't be too concerned about cutting a little bit further in that side. Well, that is something I wasn't expecting to see. The very first one of these I did only cut it off at the weld there. So that's actually a solid piece running all the way through. That's a good thing. You can see there's quite a big chunk of weld there that I actually had to break through. If I bring this up real close, there we go. So that shows roughly how far you need to cut in. That's about 10 mil. Do that with the grinder and just good luck bashing it till you break that bit. Next thing we'll do is we'll just clean up the remaining piece here. We'll grind it off flush and we'll get it set up for welding that onto there. Now that we've cleaned that down flat, we've just V'd out where we undercut those welds slightly and this one in the middle here. So before we go any further, we're just going to fill them back in and fill that up, make sure we keep the strength in it. Then we can get on with getting our anvil blocks all prepped and sorted out. Next step here is to, we're going to set the little locking tabs up. So we need to drill a 10.2mm hole. 10.5 is usually fine. I'm just going to mark and drill that and then tap it to 12mm and set these up before we weld anything on the weld these slides on the front, just so we can get a good grip in our vise. And the position side to side is not very important. You just want to get it so that the long edge sits just below, just a millimetre below the top face, just to make it easy to get our dies in and out. But that's still going to be plenty of coverage for when you rotate it. It's still going to catch the bottom of your plate. So yeah, set them up so they're just below the height. Yeah, mark them, drill them, and then might as well run through this in one step. So once we've got that done, we're going to take our initial die plates, chuck them on there. I'm going to use a piece of thin cardboard. This is 0.8 of a mil thick. It's just from a beer carton. We're going to clamp that in between there, because that'll then give us our clearance. And if it's likely to get a bit stuck when we weld it, so cardboard's easy enough. We can just heat it up and it'll burn itself out. Yeah, that's going to be the easiest way to do that. So you clamp it along here first. Clamp it that way first, and then pull it up tight, clamp it that way so it's not going to move anywhere. Just a few, probably 2 little stitch welds along the side. It's all it needs. There's not a lot of force on them, so don't get too carried away. Of course, might as well clamp both sides together, or both sides on. That means we can just use a piece of 6mm plate as a 150 by 150 square and weld whatever dies onto that we want to use, whether rounding dies, squaring dies, or any weird shapes that you want to do for your Damascus. And they'll just slide in there nicely, and they'll be nice and secure. They'll line up every time and very quick to change as well. So we're not reinventing the wheel there, just going with what works. You can see here we've got our, hold it over there, we've got our locking tab in. It's a bit tight, that's going to need a bit of a design change, maybe a bit more of a lever on it or something, but it's functional, it works, it'll do the job. You can see we've got 2 cardboard spacers clamped in there. We've clamped these down, we've clamped them across, so they're in their final position. All that's left to do now is a couple of 2, maybe 3 stitch welds. I'll just do a couple of tacks to begin with, take the clamps off and finish the stitch welds. Yeah, coming along well so far. Hopefully it's not too hard to get the plate back out, or we'll just heat up around the cardboard and that'll burn that, and that'll just fall out. Alright, we've got 2 ready to go anvil plates. So still a bit stiff, but we'll sort that out later. We're ready to, well, once this is all done, we'll weld whatever tool we want onto these plates. They slide straight in. Straight in like that. So they're interchangeable, you can spin them 90 degrees. These 2 are the same, except for we put a little stopper at the back of this one, because this will be, they're slightly offset, and this will be the top one that's mounted upside down. So that goes on the press like that. The bottom one has, this plate will sit up against there, so that's the stopper for that. But on the top one here, there's going to be a gap which is about equal to the thickness of this, which is 10mm, 12mm, whatever it is. So we just needed a little stopper on the back to stop the top plate from sliding to that height, so it stays in line with that. We're going to put these aside for now, because we don't want to go welding them on in the wrong spot, so we want to make the press operational before these get welded onto both this and onto the frame, just to make sure everything squares up nicely. Yeah, we can put these aside, they're ready to go. That's pretty much how they'll sit together, but they'll have a tool welded on them. So then on to the next step, which is going to be setting this up on the frame itself. So before we set this up, something I think I've forgotten to mention is the piece that we cut off from here, from the wedge. Keep that aside, because that can be a really useful cut-off tool or press brake tool, depending on what you want to make. So yeah, keep it aside, it's far from wasted. In fact, I think it's going to be really handy, at least for what I want to do. I'll probably use it as a press brake, so I'll have maybe 2 pieces of angle set up. You usually go 1 or 2 degrees over, so I'll set it up at 89 degrees, and then this will press down in between and yeah, give me a nice 90-degree bend with a sharp corner. But then just a matter of mixing and matching dies and tools that we make. We can use that for a hot cut or whatever, really, get creative. So yeah, keep that, don't throw it out. So since I loosely fitted it all up before, I've made a few adjustments just to make everything work a little bit better. This is probably a really good time to remind you that whatever specs I'm giving you here is fairly rough. It'll give you the gist of what we're doing. Refer to I'll do up a set of written instructions with all the measurements that are exact to your kit. So there'll be a few changes over time as things get better or find a different way to do things. Just refer to all the numbers and the specs and the descriptions and whatever in your in your instructions. So what we had was this is the top piece. So we still needed something to keep our tool plate from sliding back. I did have one big block just welded in the back because that seemed like the easy way to do it, but that gave us interference on what was left of the wedge. So we've changed one big block to 2 pieces on the ends, and we've gone and notched out these top corners to give those little blocks somewhere to go. Otherwise we'd have to cut a big chunk out of the center. At the moment that's the easiest way to do it. I'm going to explore ways to try and remove that. We might end up going to thinner anvil plates, but yeah, at the moment that's a pretty easy mod to do. You can see we've gone from just above the level with the top of the bolt head all the way across, and here we're about 45 millimeters in from this edge. So just to give you a rough guide, that's not much that we're taking out, but should do the job. Another mod that we've done is we've cut about 60 millimeters off the end of this, just so that this face here ends up being flush with the edge of the anvil face. It just gets this out of the way. It was serving no purpose, and it was a good spot to get something caught or pinched or just get in the way of your work. So I popped that in the bandsaw and just lobbed that off. These plates will be supplied in the kit too, just to weld on the end again. Now this is the bottom anvil plate. Not much changed here, except we just gave it a nice radius on the corner, on both of the back corners. So you've got the lock at the front, lock on this side, radius on these 2 corners, and gave that a nice big radius on the bottom, so it sits up like that. Nice big radius on the bottom of that. Just to clear this weld that we popped in here. That should all make sense. That should be pretty straightforward. When we go to weld this up, we are going to use these our side adjustment things. We're going to clamp them. We're going to stack one on top of each other, so that gives us 20 millimeters. So we've got our anvil plate, we've got the tool plate, we've got our 2 side adjusters as spacers, so 20 millimeters. We've got our other tool plate, and we've got the top anvil, and that is going to give us the right spacing, and we're going to put a clamp from underneath this, with this sitting on top of that, and clamp it up into to here. We'll just put a couple of tack welds and make sure everything's lined up and square and good. And then we can weld that out, and we're actually finished with the frame modifications. So remember the one with the chamfer at the bottom and a radius on the back edges. Pop that in. Looks much better now that that sits flush. And then the top one that's got the two blocks welded on the ends, also with the plate in there. Now we just want to make sure that these anvil plates are as in line as possible. So alright, now we've got them in line, we just have to put our clamp on. So we've just taken off just a smidge on that top corner. It's important that you muck around with this step for as long as you need to, just to get it right. Once it's in, it's done. So yeah, just making sure this one's all the way back, and then we're just setting the top one up to be in line with the bottom one. Having these two here, as long as they're going across the centre somehow, this is slightly diagonal, but that's fine. That will make sure that we get the top, or the two plates parallel to each other. So the top one's going to be the same as whatever the plate is, but the bottom one has a little bit of leeway the way that it sits on what was the wedge. So we'll clamp it up tight and then give it a few tacks or even some stitch welds as a temporary measure. And then when the whole thing's done and operational and we're happy with it, that's when we'll weld it up fully. Alright, it's looking pretty good to me, so we'll just crank that up. Having the clamp placed under here as well, that's going to pretty well replicate what the cylinder will do. So all the forces are going in the right place, and yeah, nothing will actually be too different in real life. So just 4 tack welds on each one, making pretty big tacks, but don't go right into the corners either. Always do your tack welds in a place where you can get to them with a grinder to cut them out, or that you can get in with a chisel or something. You just want to be able to fix them up if you do need to. Our frame is sort of 99% there. All that's left to do is fully weld out these tacks once we confirm everything is perfect, because we're not going to be not going to want to grind them out and reposition things later. At the very end we'll come back to a bit of guarding. So there's a tray that came with the splitter that we're going to use to make a bit of a guard over this side to protect the hoses. There's nothing on this side that we really need to look out for. Nothing on this side here. The next thing we're going to be looking at though is the electric motor and the hydraulic pump. So we'll run through a few options for that. In the meantime, we will just put this bolt back through. Just so nothing goes moving on us unexpectedly. Alright, now that we've got the frame sorted, we are going to get into part 3, which is the hydraulics and the motor side of things. So first thing we'll do is, we've already put up the petrol motor aside, and remember, if you do want to use the petrol motor, I'd suggest just getting longer lines made up and put the motor outside somewhere. You'll just bolt this, you'll bolt the pump with its original hardware and couplings and everything, and you can almost, or you can completely ignore this section we do about converting to the electric motor. However, I do recommend using the electric motor. I think it's a lot more user-friendly. It's quieter, it's nicer, it's easier to plug in, and all of the good things. So this is the pump as it comes with your splitter. It already has one of the couplings installed. It's got its own mount and comes with a little guard, drive shaft guard, which covers over your bits. It's got its own hardware. It's got this sleeve. This sleeve is used with the petrol motor, so ignore this, but keep the rest of the bits. And it also comes with this sleeve and the coupling that it comes with. They can both be put aside. We don't need them. Put the little guard and hardware aside for the time being, and we're going to look at just roughly how this is all going to work. So this here is electric motor. It's the 3-phase for the variable speed version. These will ship with the same spec motors as I use on the Scorpion grinders, so there'll be a 2 horsepower variable speed, and a 2 horsepower fixed speed, and a 3 horsepower fixed speed. There's quite a price difference between them, and if you're only using it for a forging press, just go the fixed speed. It's easy. If you want to be able to do press bearings and whatever, or for bending things and any fine work, the variable speed is nice. It works all the way down to, well, what have I got it set for? 20 hertz. So yeah, we're still getting full pressure. It just takes longer. So you can very easily control the speed of your press by adjusting your motor speed. All it will need is a different program. I'm not sure how we're going to run that, whether I just reprogram them to suit, or I might send out a list of instructions for programming. So the motor, it's not wired up. Just for ease of this demonstration, you'll receive it wired up to either to the variable speed drive or to a on and off switch. The other bits that you'll receive are 2 new drive couplings and the rubber adapter. So the original motor just comes with a steel on steel coupling, which frankly is quite crap. This, you have a little rubber, do it real close, a little rubber insert, which just makes everything last longer and is a lot nicer. So that just presses into there by hand, and all we have to do is, well, hopefully all we have to do is adjust this mount a little bit, different size holes, we'll get into that later. But yeah, we should just be able to hook it up. I'll just add now that there'll be one more addition to the kit that I haven't actually got yet because I was waiting to get to this stage before making it. But this here just has a flat surface on it, and our motor has a about a 3mm lip spigot, if you will. And just to make it sit nicely, we're going to have a 3D printed spacer that sits over that, so that we're actually bolting it up like we should. Ideally, I'd like to be able to remake the adapter. I'm not exactly sure how I'm going to go about that, but we're going to give it a go and yeah, see what we can come up with, something that's economical and effective. First thing to do, quite simple, we're going to use a 13mm socket. This one's on a little bar to actually fit into a tight spot, and a 13mm socket and spanner to loosen these bolts off. Alright, this should fit through. Lovely. So we've got that separate. And while we're here, we want to remove this drive coupling. So 4mm Allen key. Oh, that's tight. Very light pressure. There we go. Rescue the key from it. That no longer needed. The key back on the shaft, and we have the 1/2" side to our drive. Slides on like so. Just leave the drive coupling out, the rubber piece. I just want to make sure we can get the right length. Adjust this up so you can see probably on that angle that we've got to have these couplings right out on the end. Now the grub screw is on the shaft, which is fine, but we've got 7.5mm off the end of the shaft on this side and 4.5mm from the end of the shaft on the motor. So that's all right, but that gives us good engagement, and it'll give us perfectly fine drive. It's only 2 horsepower, so it's not like it's putting a huge amount of load through it. Most of its life it'll just be spinning pretty freely, and then as the power winds up, at least there's no shock loads on it. The other thing we need to do is these holes are built for a larger, it'd be the 100 frame, and this is only a 90 frame motor. But if we show real closely here, there's a center pop that shows the smaller down there. I haven't put those marks in there, so that's where we need to drill to be able to line up with the holes in the motor. Now I'm going to make up a template so we can either just use 2 bolts and then swap it around. I'll come up with a way to make that really easy and quick and simple. I'll just drill them out as best I can while I'm waiting for this bit to print, so I'll get that done. And just showing here how I'm reasonably accurately drilling out the second set of holes. Without doing this, the drill bit just wanders and buggers off somewhere else. So first time I tried to modify this mount, I ended up using a round file and it took ages. This way is quicker, but then I would have a plate with the kit that has 2 of the outside holes and 2 of the new holes, so you can just bolt 2 bolts through it and it braces it for the other 2, and then just turn it 90 degrees and do the other ones. So. It's getting there. See, it's doing a fairly clean job. Pretty successful. And we've just got the 3D printer here going, printing up that spacer that we need. Now that the first layer is done, we can turn up the speed. If anyone's thinking about getting one of these for their workshop, I strongly recommend it. It's a great way to make small parts, test sizes and make brackets, all sorts of stuff. It's, as long as you can design it, you can make it. So yeah, good little things. Okay, we should have most of these parts ready now. So we've got our motor with drive coupling and the grub screws tightened up, 3mm Allen key for that. Just nip it up nice and tight. Refer to your instructions that come with your kit for the depth, but I've got 4.5mm protrusion there. We've got a spacer ring, so that sits over that. It's firm on that inner ring. We've got our adapter with the second set of holes drilled out so that it matches this. It's the top of the motor, which is going to be facing out, which is where we want the opening to be, so we can adjust it later if we need to. Alright, so we can bolt that on. So these are the bolts that actually came with the hydraulic pump. And the spring, I hate using spring washers. They are unreliable. Alright, so 13mm. I'd love to be able to print out a nice little adapter housing. I've got some ASA I might try doing that with. It's a bit of a hard wearing plastic. But that's going to need a lot of testing before I can be sure it's going to actually last. Alright, that's on, that's on. We're going to put the rubber vibration thing in there. Okay, and we got to think about this. That goes. All right, looking at the top of the motor, where your junction box is, we want the suction side to be on the right. Ooh, lucky that fits. Plonk that on there. Look at that, this might actually work. This is exciting. Alright, one last thing to put on is our little drive shaft. Just a little tip to make things nicer is I've lined up as close as possible where the two grub screws are. That way, if you do need to make any adjustments later, they're pretty much in the same spot, so you can get to them. You can just loosen one of them off, push it down, line it up, whatever. It's fine to have a very small gap in here between the two. That just stops it from fretting and whatever. I wouldn't go any more than, it's probably a millimetre. I wouldn't go any more or less than that. It's really just a good spot for it. And luckily the coupling is a bit bigger than the original one, but our guard still fits. Just need a 8mm socket or spanner for these tiny little ones. That's all come together quite well. I'm happy with that. On to the next step. Alright, what we should have now is motor and pump all bolted together. From the splitter hardware, there should be 4 M8 by 35 M8 by 35mm bolts, 4 nylock nuts, 4 flat washers, and in the kit I need to supply an extra 4 flat washers, so we've got 8 in total. And we're going to put these bolts with the washers through the feet so I can jiggle it around and line it up on these holes here. The motor goes upwards, as you'll see, and yeah, just bolt it up basically. This would be easier if it was lying down. If you've got a crane or a forklift or something, now's the time to do that, but it's actually getting pretty heavy and it's pretty stable, so it's a fair effort to even get it tipping, and I'd rather not bust my ass trying to lift it back up again, so I'd rather just lift a motor, which isn't that easy, but it's not too bad either. Your nuts ready. just got one in and I've got the weight of the motor sitting on it, so it stays where it's meant to. There we go. Easy. Uh, 13mm socket and spanner to tighten them up. There we go, easy as. Got the motor on. Now remember, this would be wired up already. So the next things we need to do is we're going to start hooking up these hoses in some sort of neat fashion that keeps them out of the way. Alright, getting to the business end. This is the suction hose that the splitter comes with. We're not going to be able to use this hose, it's way too short, so take the clamps off it. I'm using this black hose, it's an oil hose, but it was all I could get at short notice, but I'll be getting some clear so you can actually see when there's oil in it. Chuck that aside. There should be a little red cap in your hydraulic pump, and we taped over the outlet of the tank. So slide your clamps on the hose and shove it on. It should be quite firm. If you're really struggling, use a little bit of hydraulic oil in there to slide it on, but it will actually seal better if it's dry, so keep them dry. That one's a little bit easier. Use a screwdriver, make sure you tighten your clamps up. Okay, nice and firm. Next, grab yourself the 2 brown O-rings that came with the splitter in the bag of nuts and bolts. You need a shifter and probably a screwdriver too. So we'll start with the pressure line, which is the long one. It runs right around to the front of your little control valve. That needs to go on to the hydraulic pump. So pull the little protective cap off. Use the smaller of your 2 brown O-rings. Pop it on the end there. Screwdriver to get that plug out. And wind that onto your fitting on the pump. Tighten it up with the spanner, don't go crazy on it, it's got an O-ring. Now, this is the return line, so this comes from the back of the control valve, which is at the moment, which is closest to us. That comes back into the tank. This is where all the oil returns, but you'll see It doesn't sit real, well, it doesn't sit nice at all. We could, that's actually not bad. Yeah, we're going to round it up that way. And we don't even have to loosen it off. If you can't get that face to go on there the way you want it to, you just have to loosen off the other end of the hose and then rotate it, get this one on, and then tighten the other side back up again because it's got a straight on that side. So but we're going to do this one like it is. So same again, remove the cap, use the larger O-ring, make sure there's no crap in there. Screwdriver, pull that out. Ugh. There's a little bit of oil in this hose. Nice. And a bit of paint on the bed. That's okay. Tighten it up. Once again, don't go crazy. Wipe up your mess. Now I should say at this point, if you do want to put a pressure gauge on this, which it's good to know what pressure you're getting, and then you can calculate your tonnage, but if you're watching a gauge, you're watching the wrong thing. This is something that you're going to have to learn to use by feel and what it sounds like and what it feels like and what it looks like. And yeah, watching a gauge isn't going to give you that feedback that you really, really need. But I would suggest, before we go any further, that you would take the fitting out of the pressure side of the pump. You'd install a T in there and run lines from that T up to wherever you want to mount the gauge. Because then everything's kept at the back here and it's neat and it's out of the way and there's less damage that can be done from any steel that's falling around the front. So I'm not going to put a gauge on this one. I did on the other one just to check what pressure we're getting and was quite impressed, but I don't need to do that. Make up your mind, preferably before you fill the hydraulic tank. It just makes a mess otherwise. We might put a couple of cable ties on these hoses just to make sure that they're not rubbing, and get on with the next part. Alright, one last part of the hydraulic system to address is the control valve. This bit's quite simple. All we have to do is pin the handle through the top of the valve. It's just a matter of pulling out a split pin, popping that out. Got to find the hole. There we go. Put it in. Now you'll see that would be up motion. Obviously, we're pulling it up. But to go down, it's got a detent, which is like a auto retract. So as a log splitter, you would be holding that to split your log, and then once you do split it, pop it in that, and it's going to go all the way back. And once it pressurizes up, it pops itself out again. But that's while you walk off and you grab another log. But we're not doing that with this, so you can leave that if you want. I thought it would be useful, and it's great when you finish pressing whatever you want. You can just push that down, walk away, and it goes back to the bottom, shuts itself off, and you're good. It's actually quite a pain in the ass and makes it difficult when trying to. You actually have to pull it back up every time. It's quite a quick and simple fix. We need a 6mm Allen key and a shifter. We've got our control valve here. We've got the lever, obviously. Going up is no problem. Going down, it holds it in a detent. We want to get rid of that. So that's controlled by a little bowl in here. So at the very bottom, there's a plastic cover. We can unscrew that take our 6mm Allen key and a shifter. Back off that lock nut. We want to wind this anti-clockwise from Allen key's perspective until, so we're just going to drop the little ball out. So very carefully. Now no oil should be coming out of this, so you can do this, you can wait until you get it running and see if you want to change it later. I just know for sure that I want to change it now. So very carefully pull your grub screw out. As you drop it down there'll be a spring. Grub screw, you can see the spring. Ball bearing and a little slug. Instead of having the got the spring, then the ball bearing and the little slug, we're going to take out that slug and the ball bearing. While we're at it, keep the spring with it too. So there's nothing going in there anymore. Just put it halfway in, just to make it happy. Lock it up. That's good. So now you can see the lever doesn't lock anywhere. Put that plastic cover back on. Lovely. So that hydraulic system is now ready for oil. That's still going to be the very last thing that we do. Now the next thing we want to do is work out where we're going to mount the switch. I've got two places in mind for two different options. Option one, which would be on the fixed speed machines, is you would have a switch that looks like this, with a simple on and off push button. So there's this plate that obviously this will bolt straight to that. At the moment, the place I'm thinking that is least in the way is up on top. So if you're going to run the single speed, just grind off a bit of the paint on top. It's fairly thin stuff anyway up there. Welds plate on and enjoy. It should be quite simple. If you're too short, well, don't put it up there then. But it means you're not going to drop anything on it. You can reach it from the front. It's fairly central. Anyway, that's my choice. You can put it wherever you like. That's just where I think I would. Option two is the variable speed drive. Now, I don't really like the idea of that being on top just because they are so bloody expensive. So for this, it means you do need to be able to get to the on and off button, but you can also hook up a remote to this, so you could have a remote switch wherever you wanted, even up on top, to be able to adjust your speed, start it and stop it, whatever you wanted to do. I am going to mount this one around underneath the hydraulic tank on the side, so it's facing the side of the machine. So I'd put it down here. It's nice and out of the way. It's protected from things falling on it. It's near the motor, and it's still accessible as long as you don't jam this into a hole. So either way, this kit will come with a mounting plate for the back of this, so you just bolt it straight up to that, or that wherever I put it, that plate I showed you earlier for the just the on and off switch, which you can also mount wherever you like. There'll be about 2 meters of cord to play with, so that's not really going to be a big drama. Yeah, down there it's nice and out of the way, it's fairly protected, and like I said, they're pretty expensive, so you don't want to go putting this in a place where you can do too much damage to it. You do have the risk of dropping something on it. If you're worried about that, make a quick little sheet metal guard for it. So for now I'm just going to go ahead and mount some brackets on there so I can actually put it down there. And there you see we've mounted a variable speed drive onto the side. I think it's out of the way enough. I'll give it a bit of testing, but I guess it's one of those things. Make sure you check the instructions with your kit. That'll show you exactly where I've intended to put it, and also any additional guarding that it might need. We might end up with a bit of a piece that sticks up here or goes across to the tank just to keep it all clear. We'll see how it goes. So I've just done a quick mock-up of the guard we're going to make to cover all the hoses and the valve. Basically it consists of, as part of the kit, there'll be a right angle bracket that uses one of these bolt holes, and there'll be a long bracket underneath, which I'll show you in a sec, which uses two of the mudguard bolt holes on the side of the hydraulic tank. Those two brackets will just they'll need to be welded onto this plate here. Comes with your splitter kit. No, it comes with your log splitter. The other two brackets will come with the kit that I supply. All we have to do is trim it, so we'll cut it off so it's almost flush with the hydraulic tank, which makes it almost about roughly half the size, and that will prevent pretty much everything from falling down here onto hoses and back onto the pump and onto the control valve. Even your hand's a bit protected, but there's still plenty of space here to be able to move. You'll see it's just a bit of flat bar for now, but we'll make it a little bit nicer, of course. But yeah, this is supporting up the side and that the other side, and that should be enough to deal with anything that we drop. So now we've got a bit of a guard. We can use it as a bit of a shelf. We don't want to be putting too much weight onto it, but it's going to protect all the hosing, the valve, all that from most things. Only two jobs remaining is to weld our dies onto our plates, fill it up with hydraulic oil, and start using the thing. Just welded up our dies here. We've just made some, they're 26 mil wide, 90 mil long. It's actually a bit of SUP 9 5160, just from a piece of flat bar that I cut. Just something simple to try out. It's really an endless game of how many dies you can make to do however many different things you want to do. These haven't been heat treated, they're just as new stock, annealed. But they'll be a lot tougher than mild steel anyway. Last step in this process, a very exciting step, Remember, double check, make sure all your hydraulic hoses are on and tight, and you're happy with the setup. Now you get to watch me spill oil everywhere, so that's going to be fun. I'd use a funnel, but I can't find any. From memory, it takes just about this whole container. This is going to be bad. Oh, you'll be okay. Can't believe that. One take. Didn't spill a drop. Go. One drop, that's not bad. Double check everything looks good here. And it does. I could hear some bubbles coming up somewhere. Avoid the temptation of just starting it up now. It's getting pretty late. I might as well leave it to settle overnight. Hopefully that should get any air bubbles out. And it's a gear pump, so they are self-priming, but you don't want them running dry for long. Give them the best chance possible. Even just jiggling this hose, get more bubbles coming through. So we're just going to let that bleed out over the next, well, overnight, and in the morning we're going to fire it up. Alright, ready for the moment of truth. This is the bit we've been waiting for. All our bolts are tight, all our welds are good. Hydraulic tank is full. Yes. Hydraulic tank's full. Motor is on and tight and wired up. Nothing's leaking so far, just under gravity. We've got a variable speed drive down here. Our cylinder looks good. Our valve has been, well, we've removed the detent from the valve. Our shelf is in, and we've made up some basic tools to use. So the advantage now of having a variable speed drive is the first startup, you can just ease it into it, and it would be running at 20 Hertz, which is about 500 RPM. Not that that's really a big deal, but if you've got it, do it. If you don't worry about it. It's going to get quieter as you use it. Even just getting the air out of the system is going to make it quieter. And then, well, the last one I did, I used it the first 2 times, and it was making a bit of foam in the oil. I left it for a couple of days, came back to it, and not a bit of aeration since then. So I think it just needs to have. You just need to work it until everything's bled and everything works the way it should. So, power. I'll probably trip over that. It's set at its lowest speed. I'm just going to push the start button and hope it's all good. Yeah. Sounds normal so far. Let's see if it works. Hey! Look at that. There we go, see it's quieter already. It is very slow, remember that is at the very lowest speed. Just going to give it full stroke. They're lining up well though, which is nice. There we go. You hear those noises, that's just air running through the system. Building up pressure. What I found with the last one I did as well is, for a while, the relief valve wouldn't go off, the motor would just stall. After I used it, well, 2 or 3 times again, that just came good. The relief valve started cracking, and it would just keep pushing through. So I'll turn it up now. I'll turn it up to its full speed, and this would be the speed that a fixed speed machine will be running at. So it's going to get a little bit noisier, but you'll see how much faster it gets. Speed is important, so I've marked a line every 50 millimeters, which is pretty much 2 inches. You can see for yourself just how fast this actually moves, and yeah, just keep in mind that it is a 2-stage pump, and when it is under load, it will slow down, but that's the cost of running this off a 2 horsepower motor as well. If you wanted this sort of speed with a single speed pump, you're probably looking at about a 20 horsepower motor. That's not really feasible in most situations, so we're working with the best that we can, and at least this means that any free space, so you can have your dies open and you'll close those dies up really quickly, and then it'll be able to work your steel at a good rate. After you've run it up and sort of given it a little bit of a warm up, make sure you check your oil. We're just on the low mark, so we're going to top it up a smidge. Now we'll probably spill this everywhere. Now that gives you an idea on how much oil it takes. So it's pretty much the full thing. You've got a little bit left over for if you spring a leak, or if you want to drain it and you lose a little bit, you're all good. Remember to check over everything before you use it every time, and keep an eye on it during use. Make sure your hoses are fine, make sure you've got no leaks, make sure your electrical stuff is in good working order and your cords aren't damaged and whatever. If they need to be tagged for a workplace or some other reason, make sure it's all in date. All that stuff. If you get the variable speed drive, make sure you follow all the precautions that come with that in that manual. Wear the right PPE, hearing protection, gloves, glasses, all that sort of stuff. As much as you feel you need to take care of any risks from this, a press is a fairly universal tool. You'll find 1,000 uses for it. Just make sure whatever you do, you're keeping yourself safe, and you're not hurting yourself, you're not hurting the tool, and watch out for others around you as well. Apart from that, we are good to go. Enjoy using this thing. It's going to be a very handy tool in your workshop. Remember, this is what I would call a light duty machine. It's if you need something for 8 hours a day, 5 days a week, you're always better off going for a stronger, heavier, commercially designed, purpose-built something. But this is aimed at hobbyists and people on a budget, of course. It's going to do a lot of work as long as you look after it, and hopefully this has given you an indication more than anything that the kit that you can purchase from me and converting one of these log splitters, hopefully you've seen whether it's within or not within your capabilities. I've tried to show every process as best I can using the tools that I've got. If you've got different tools that do the same thing, well, that's fantastic, that's great. If they do a better job, then that's even better as well. If you see me doing things to put this together that you can't do, your options really are to outsource that work, or if you're not going to be able to outsource it or do it yourself, then this project is not for you, and I'd recommend buying something pre-made, pre-built. That may or may not be by me. That's entirely up to you and the situation that brings us to that point. But hopefully I've showed everything in a simple enough way that you see you can do it. There's no great structural welding. There's a few welds that you do want to be particularly strong, especially the ones around here holding welding the anvil plates to the frame and to where the old wedge was. Only other thing really is you might have trouble cutting the if you don't have a bandsaw like I do. It'll be a struggle to cut the top of the wedge off. I'm going to assume that if you've gotten this far, you've seen that this is a project that you want to do, and whatever comes of that, you're going to give it a go. That's great. There's 1,000 ways to do it, but that's a good way. Now remember again, this kit, this is the very first version of this kit that I've produced. That's why I've built one using the kit. I've found quite a few shortcomings. That will all be fixed up in the next one. There'll be no brackets to make. There'll be no almost no measuring, like where the VSD goes, there'll be little tabs, so that bracket just slots in. These bits here to hold the shelf on, they'll be a bit sturdier and pre-made as well. So most of it is just a bit of lining things up and drilling some holes in the back, standing it up, whatever, you get the idea. Any questions, please ask, and this will be a YouTube video. Please hit the subscribe button and the thumbs up if you liked it. Every click does help quite a bit, especially on a smaller channel like ours. So yeah, any just hitting subscribe makes a massive difference. I hope you do, and I hope you get to see how this project evolves over the next little while. Big thanks for watching, and good luck. Have fun with your press.